Hi, in this video, we will talk about the derivative of polynomial functions and exponential functions, okay? First, I would like to introduce the notation that we are using in this video then. So, the derivative of a function y equal to f of x, it may be represented by the following, like f prime of x, y prime dy dx. So if we have y equal to f of t, then in this case, the derivative of y is dy dt then. Okay, so some vocabulary here. Differentiate means find the derivative of. Differentiations refer to the process of finding the derivative. And differentiable is a function whose derivative exists for all values of x in its domain then. We also need to talk about the higher derivatives. So when we talk about the second derivative, what does this mean? It means that we have a first derivative, and then if we take the derivative of the first derivative, this becomes the second derivative. And the notation will be d squared y over dx squared, or we're using y double prime or f double prime of x. Then if we take the derivative of the second derivative, it's become the third derivative now. Okay, so sometimes we're using the y triple prime, f triple prime of x. Okay, then now if we want to have a higher derivative, like for example n derivative, then we are not using the prime notation anymore. Instead, we are using kind of like the superscript f superscript of the parenthesis of n of x then. Then back to like a speed and also acceleration, right? So if I have a position function s of t, then when we talk about the velocity, it's the first derivative of the s function, the position functions. And the acceleration a of t is the first derivative of velocity, or we could say that is the second derivative of the position function then. Okay. Okay, so now, then let us look at couple rules that relate to the derivative now. So if y equal to c, where c is a constant, then what is y prime? Okay. So if you remember that if we have a constant, it means that we have a horizontal line. Okay. In this case, the slope of this line is actually equal to 0. Okay. So then in this case, of course, if we want to take the derivative of this constant function, then my answer must be 0 then. Okay. Okay. So how do we write the notations? For example, if I have f of x equal to -3, okay, again, -3 is a constant, so I could write down f prime of x, okay. Or we could use the notation here. It's kind of like we take the derivative with respect to x of the number -3, right? Then my answer will be 0 then, okay. And now, how about if we have e squared? Again, e is a constant. So when we have a constant to the square, it's still a constant. So therefore, when we try to take the derivative of g prime, again, is equal to 0 then, okay? Then the next rule that we are going to learn is the power rule, okay? So in this case, if n is any constant, what does this mean? It means that n could be positive, negative numbers, even 0, okay, as long as it is a constant. And y equal to x to the power of n, meaning in this case right here, we have a power function then. Then the derivative of y, it will be n times x raised to the power of n minus 1. Okay. So in this case, basically, the idea about taking the derivative of a power function is we bring the power down to make it become n times, and then we subtract 1 from the power. Okay, so this is the idea. Then now, let us look at our first example. Okay, so to this one, if I have f of x equal to x, then of course, if I want to find the derivative, okay, then we know that to this one, the slope is actually equal to 1, meaning f prime of x must be 1 then. Okay, now let's see if we apply the power rule to see if we get the same result. So then I have f prime of x is equal to, again, remember if I have x, meaning I have x to the power of 1. So I bring the power down, x 1 minus 1. So then I have x to the power of 0. Then we know that x to the power of 0 is 1. Okay. We got the same result, right? Must, right? Okay, then now, how about if I have x to the power of 6, then when I write down, again, when I find the derivative of h, it will be, we bring the power down, and then we will have x, and then we subtract 1 from the power. Okay. Then my answer will be 6x to the power of 5 then. Okay. And now, how about if I have a negative? Okay, again, -2 is a constant, so we could apply the power rule here. So I will have y prime, okay, is equal to, we bring the power down, -2, x to the -2 minus 1. Okay. Then I will have -2, x to the -3. Okay. Well, and this is my answer. Okay. Now, of course, if you remember, we could rewrite this. If I want to have my answer has a positive power, then x to the -3 basically is mean that it is 1 over x to the power of 3, right? So we could write this answer right here into -2 over x to the power of 3. Okay. Then now, what if I have the function is like 1 over x to the power of 6, okay? Now remember, in this case right here, we cannot apply the power rule to x to the power of 6 here because we have to consider the whole expression, okay? What I need to do, basically, I need to rewrite 1 over x to the power of 6 to x to the power of -6, okay? That means we need to rewrite the expression that we have to the exponent form first, okay? So then this is actually my first step. I would like to rewrite this into x to the -6, okay? And then from there, we are going to work it out the problem now. So I will have f prime of x, okay? Now, before we move on, I would like to introduce the notation that I'm using for derivative. To me, I will use the square bracket with the prime. This tells me that I'm going to take the derivative of these functions, x to the power of -6 then, okay? And now my answer will be, we bring the power down, we subtract 1 from the power, okay? Then I will have -6 x to the power of -7. Okay. Okay. So, and now, usually I like to do it this way. If the problem that I start with, okay, has a positive exponents, then I like to rewrite the answer. Okay. As a positive exponent as well. Okay. But of course, on the test, if you leave your answer like this, then you got the right answer already. Okay. Then now, what if we have a square root of x? Then remember, if we have n root of x to the power of m, we could rewrite this into exponent form, x to the power of m over n. So then I would like to rewrite square root of x to x to the 1/2 then. Then now I will have y prime is 1/2 x to the 1/2 minus 1. I have 1/2 x to the power of -1/2 then, right? Okay, then now, again, let us rewrite this to a positive exponents. So then I will have 1/2 multiplied to 1 over x to the 1/2. Okay. And of course, I know that x to the 1/2 is square root of x. And my answer will be 1 over 2 square root of x then. Okay. Okay, so now, then let us continue. The next example that we have is related to the constant multiple rule. Okay. Now to this one, I have a lot of students when they see a constant, they feel that when they take the derivative of the constant, it is equal to 0. In fact, it is correct. However, if you have a constant multiplied to a functions, then this is not the case now. Okay, let's see how we actually work with this constant multiple rule then. If C is a constant and F is differentiable functions, and G of X equal to C times F of X. So we have a constant multiplied to a functions. Then the derivative G prime of X is equal to C times F prime of X. Okay. So it's not equal to 0. Okay. So just keep that in mind. Then now, how do we take care of this? And the idea is will be F prime of X. We take the derivative of the function F. I would like to take out the constant 3 and multiply to the derivative of x to the power 5. Okay. Now remember again, the notation is using the square bracket and close the functions and with the prime notations. That means I'm going to take the derivative of x to the power 5 next step then. Right? So I will have -3 and multiply 2. I bring the power down 5. X to the power of 5 minus 1. Okay. Then I will have -3 times 5 is -15, x to the power of 4. Okay, then this is my answer then. Okay. So number 9 is a little more complicated. Okay, so again, we base on what we want again. We write this into exponent form first. Okay. Then in this case, what I would like to consider is I have 1 over 2 multiplied to 1 over 4 root of x. Okay. Then in this case, it will be 1 over 2 multiplied to 1 over x to the power of 1/4. And I will have 1/2 x to the power of negative 1/4 then. Okay. So y equal to 1/2 times x to the power of negative 1/4. Okay. This is my calculate the first step, and then now I could take y prime is 1/2. Okay. Then I take the derivative of x to the power of negative 1/4. Okay. 1/2. I have negative 1/4. We bring the power down. X negative 1/4 minus 1. Then again, negative 1/4 minus 1 is negative 1/4 minus 4/4, which is equal to negative 5/4, right? Okay. So 1/2 times negative 1/4, okay, it will give me negative 1/8. Okay. So I have x to the power of negative 5/4. Okay. Then now let's see, okay, let's see how we actually simplify these expressions now. So what we could do here is we could write down as negative 1/8. And then 1 over x to the power of 5/4. One over 4 roots of x to the power of 5. Okay. Then in this case, I could take out x to the power 4 and x to the power 1. Because in this case, I decompose the x to the power 5 into x to the power 4. X to the power 1. Okay. Then now, of course, we know that this is equal to x. Okay, so my answer will be negative 1 over x times 4 root of x then. Okay. And now let's see how do we actually work with the sum and the difference rule. Okay. So if I have if h of x is equal to the sum or the difference of f of x plus g of x or f of x minus g of x. So when we take the derivative of h, basically it means that we will take the derivative of f of x plus or minus the derivative of g then. Okay. So then now let's see the following example now. So I will have f prime of x. It means that I would like to take the derivative of 3x to the negative 4 plus the derivative of 4x squared minus the derivative of 5x and add the derivative of e then. Okay. Then now I would like to apply again the constant multiple then. So I will have 3 times x to the negative 4, the derivative of x to the negative 4, plus 4 times the derivative of x squared minus 5 times the derivative of x. And of course, e is a constant, so the derivative of e is 0 then. then now I will have 3 times negative 4 x to the power of, again, negative 4 minus 1 is negative 5, plus 4 times 2x and minus 5 times, remember the derivative of x is 1, right? So I will have negative 12 x to the power of negative 5 plus x minus 5 then. Then this is my answer here. Okay, so now then let's see, how do we actually take the derivative of e to the x? Okay, exponential function then. So in this case, I would like to use the definitions to take the derivative then. So remember the definition tell me that if I want to find f prime of x, it is equal to the limit h upon 0 of f of x plus h minus f of x divided by h. Then now, okay, so again, remember f of x equal to e to the power of x. Basically, it's kind of like we have the input has a box, then we are going to, again, work with the expression e to the box then. So the limit h upon 0 of e to the, this is the box that we have, okay, e to the x plus h minus e to the x over h. Okay. And of course, if we know that e to the x plus h basically is e to the x times e to the h. And now we have e to the x, so we could factor this. Okay. Then now, remember, one thing about this is if I have a times b over c, I could rewrite this into a times b over c, right? Okay. So this is exactly what I'm going to do here is I would like to rewrite this into e to the x times e to the h minus 1 over h then. Okay. Then now, the limit law tell me that I could rewrite this into the multiple of two limits. Then we know that the limit h upon 0 of e to the x is just like e to the x. Okay, because again, in this case, again, the limit only effect work with the h, right? Effect the h, not x. So therefore, in this case, to the limit e to the x, just like constant then. Okay. Then now the trouble is this one. Okay. In this case, right here, you see that if I have has h go upon 0, e to the power of 0 is 1, minus 1 is 0. So we have it in determinant form, okay, to this limit. And we have a hard time to isolate or simplify this h in the denominator, okay? We have no way to cancel out this h right now. So what I need to do, probably I need to use a calculator to help me to find this limit now. So what I will do is I will use a calculator where we has h equal to 0.1, h equal to 0.01, h equal to 0.001, right? Make h is getting smaller and smaller. Also, h is equal to negative 0.1, h equal to negative 0.01, h equal to negative 0.001, right? Something like this. To see if the result, okay, the output that I have is approaching to a number then. Yeah. Okay. So now I input my y1, okay, equal to e to the x minus 1 divided by x. Then now I would like to call the functions. And I would like to put that in 0.1. .01, .001. And you will see that the output that I have is getting closer and closer to 1. Okay. How about if we work with negative? Okay. Negative 0.1. Negative 0.01. Negative 0.001. Okay. And again, you will see that the output that I have, okay, when x equal to, that means the number is getting closer and closer to 0. Again, my output is getting closer and closer to 1. Okay. So in this case, is tell me the limit h approach 0 of e to the h minus 1 over h is equal to 1. Okay. So then now I actually get that the derivative of e to the x is e to the x. Wow. You will see that this is really special functions, e to the x exponential functions, okay? The derivative is the same expression e to the x, okay? Okay, so now let's see how we work it out, okay? Some example now. Okay. So when now I have f of x equal to e to the 5, okay? Now, let me give you some choices, okay, of the answer, and then let's think about this, okay? Kind of like multiple choice, okay? Is f prime of x equal to e to the 5, okay? Is f prime of x equal to 5e to the 4th, okay? Is f prime of x equal to 0, okay? Let's think about this, okay? And I hope that you choose the answer f prime of x is equal to 0, okay? Why not these two? Okay. The reason is e to the power 5 is a constant. Okay. So that's why when you take the derivative it must be 0. Okay. And remember, e to the x is a function, right? Okay. E to the x is exponential functions. So therefore, the derivative is e to the x. But e to the 5, this function right here is a constant function. So that's why when we take the derivative, it is equal to 0. Okay. So in calculus, from time to time, you will see that we would like to use a constant. That's mean using A, B, C that's mean to represent a constant, or sometimes we're using K, N, right? Okay. So this actually is one of the example. This function right here is B of Y, meaning the variable in this case is the Y. So then this is the variable. Then what happened? What is C? C is a constant then. Of course, we also know pi is also a constant. Okay. So therefore, to work it out this problem, then we have a constant multiplied to a functions. So of course, in this case, if I want to take the derivative, it will be C times the derivative of y raised to the power of pi then. Okay. Then now, remember, y raised to the power of pi is a power functions. So now we have to apply the power rule to take care of this y to the pi then. We bring the power down and we subtract 1 from the power, right? So my answer will be C pi y to the power of pi minus 1. Okay. Then now let us look at number 13. Okay. E to the x, it is exponential functions. Okay. But what is x to the power of e? This one is a power functions. Okay. So therefore, if I want to take the derivative k prime of x, exponential functions, so I know that I will have e to the x here. And now to the power functions, then I remember that I need to bring the power down. Okay. And then I subtract 1 from the power. Okay. That's it. So this is my answer. Then now, how about if I have 3x minus 5 raised to the power of 2? Then, in this case, what I need to do, basically, I need to expand it first, right? Okay. So again, a minus b to the square is a square minus 2ab plus b squared. So then I will have y equal to 3x to the square minus 2 times 3x times 5 plus 5 squared then. Okay. Then now I will have 9x squared minus 30x plus 25. Okay. Then y prime, now I take the derivative. I have 9 times the derivative of x squared minus 30 times the derivative of x plus the derivative of 25. Then the derivative of x squared is 2x minus 30. The derivative of x is 1. And the derivative of 25 is 0. So my answer will be 18x minus 30 then. So this is my y prime. Then now we have a position function, okay, for number 15. And I would like to find the velocity and also accelerations then of the functions, okay? And remember, velocity is the first derivative of the position functions. And accelerations is the first derivative of the velocity or the second derivative of the position function then. Okay. Okay. Then if you remember this, then now we could find out that is V of t is S prime of t equal to the derivative of t to the 4 minus 2 times the derivative of t to the power 3 plus the derivative of t squared minus the derivative of t then. Yeah. Then I can write down is 4t to the 3 minus 2 times 3t squared plus 2t minus 1. Then, of course, I will have 4t to the power 3 minus 6t squared plus 2t minus 1. Then now, accelerations is the first derivative of t, okay, or the second derivative of s. Okay. Then we got the result. We got v of t already. Then why don't we take the derivative of this? So I have 4. We take the derivative of t to the power 3 minus 6 times the derivative of t squared plus 2 times the derivative of t and minus the derivative of 1. Then, of course, I will have 4 times 3t squared minus 6 times 2t plus 2 minus 0. Okay. 12t squared minus 12t plus 2. Okay. Then this is my acceleration then. Okay. Okay, so now then well, let us work with another more difficult, okay, problem then. Right now, I would like to find the equation of the tangent line and the normal line to the curve at a given point. Okay. Then now we know what tangent line is, but what is normal line then? Okay. Okay. So the normal line to the curve C at a point P is a line through P that is perpendicular to the tangent line at P. Okay. So if you look at the picture, okay, if this is the function f, then now, if this is the point at A, x equal to A, and of course, right now, okay, this will be your tangent line. Okay. Then now, the normal line will be the line go for the point. Okay. Again, this point will be I name this point is A, f of A then. Okay. with the, again, these two lines, the tangent line and the normal line, they are perpendicular of each other. This is the idea. And then we remember that the relationship between the slope of the normal line times the slope of the tangent line, it must be -1 because they are perpendicular to each other. So then let's see how do we actually, again, work it out this problem then. Okay. I would like to kind of like to separate kind of like step and procedures and then try to see if you could follow this then. Okay, again, first, I would like to find the equations of a tangent line. Okay. And remember, in order to find the equation of a straight line, we need the slope and then we need a point. Okay. So then in this case, so therefore, my first step, I would like to find the slope of the tangent, which is the f prime of x, or in this case, it will be the y prime. Then second, I would like to find the slope at x equal to 1. So I'm going to evaluate y prime at x equal to 1. Okay. This will be the slope of the tangent now. And then number 3, we are going to use the Poisson form to find the equation. Then I will have y minus y sub 1 equal to m x minus x sub 1. Okay. Of course, in this case, my y sub 1 and x sub 1, basically it is a and f of a then, right? Mm-hmm. And now, if I want to find the equation of the normal, then again, I need to find the slope of the normal, which is negative reciprocal of the slope of the tangent then. Then we will use the Poisson form again to find the equations of a straight line, right? Okay, so this is kind of like the idea. Okay. Mm-hmm. Then now let's see how do we actually again to work it out a problem. Okay. So my first step, I would like to find y prime. So I have y equal to x squared minus x to the power 4. Then of course my y prime is 2x minus 4x to the power 3. Okay. Then now I would like to find the slope of the tangent, which is the y prime evaluated at x equal to 1. Then it will be 2 times 1 minus 4 times 1 to the power 3. So in this case, it will be -2 then. And then now we would like to find the point Then, of course, the point in this case right here, it will be 1 and 0, isn't it? It is given from the problem. Okay. If it is not given, basically you could plug it in when x equal to 1, then have 1 squared minus 1 to the power 4 is equal to 0. Okay. Okay. Then now we are going to use the Poisson form now. Okay. Because we have the slope of the tangent is -2 and the point is 1, 0. Okay. So again, remember this basically it will be x of 1 and y of 1. Then now I will have y minus 0 equal to -2, x minus 1. I have y equal to -2x plus 2. Okay. This will be my tangent line. And now I would like to find the equations of the normal line then. Okay. And now the slope of the tangent is -2. Then of course the slope of the normal, it will be the negative reciprocal, which is 1/2 then. And we still have a point. It must be the same point. So which is 1, 0. Okay. Then again, plug it into the Poisson form. And we have y minus 0 equal to 1/2 x minus 1. Okay. So this will be the equation of the normal line. Okay. Okay, so then now let us look at our next example now. Okay. So the next example, again, I would like to find the equation of both lines that are tangent to the curve y equal to f of x equal to 1 plus x to the power 3. And it is perpendicular to the line 12x minus y equal to 1. Okay. Okay. So then in this case, first of all, I know that I need to find two tangent lines to this problem. These two tangent line is they are parallel to the 12x minus y equal to 1. Okay. And now let's see how do we actually work it out the problem then. Okay. Then first, maybe let us try to sketch the this straight line, and then to see if we could get any information, okay, from this line right here. Okay. Okay. So my first step is I would like to find oh, maybe let me draw this first. Okay. I would like to graph 12x minus y equal to 1. Okay. On this function right here. Okay. Then my first step is I would like to rewrite this into the slope intercept form. Okay. So now I will move the negative y to the other side of the equations. So I will have 12x minus 1 equal to y. Okay. Then okay, I need a ruler. Okay. Then to this one, I have the y-intercept. Okay. the y-intercept is -1, and the slope is 12. So I will have this one is -1. And the slope is 12, meaning I go up by 12 units. So this is 11, 12, and then 1 by 1. So it is somewhere here, okay? Okay. So then now, okay. Then of course, you will see that this line right here, it will be y equal to 12x minus 1. Then. And then now, what I would like to do is, okay, again, I would like to yeah, that's good. Okay. So right now I would like to draw the two tangent line that is tangent to the curve. Okay. Okay. And now you should notice that the two tangent line maybe I call it this is L sub 1 and this one it will be L sub 2. Okay. Now these two tangent line it has the same slope, right? Have this straight line because they are parallel. Okay. So we just notice that the slope of the two tangent line okay, is 12. Okay. So in this case, okay, again, why this is equal to 12, the reason is the tangent line is parallel to y equal to 12x minus 1. Okay, parallel to this line right here. So that's why the tangent line must be 12. Okay. Then now, in order to find the tangent line, what we need, okay, again, in order to find the tangent line, we need slope of the tangent, which is 12 already. Then we also need points. Okay. Okay. Then now we don't know point. Okay. But I know that it is somewhere. Okay, maybe let me guess that okay, somewhere here and then somewhere here is actually touching the line. Okay. So if I could find out these 2 points right here, then I will be able to find again with this point with the slope, I will be able to find the tangent line L1 with this point, okay, with the slope, again, I will be able to find the L2 then, okay. So then now, maybe let me label that. This is a 0.1, this is a 0.2, okay. If I could find point 1, P1, and P2, then seems that I'm done with the problem then. Then, how do we actually work it out? What we could do here is, we could actually, again, these actually give me the idea, how do we actually locate the point, okay? The reason is, we know that, in this case right here, I would like to set f prime of x equal to 12, okay? Again, why f prime? Because f prime is related to the slope of the tangent, right? Then, if I set it this way, what I need to do is, I need to solve for x, then I will be able to locate the P1 and P2 then, okay? Okay, so, and now, let's see how to find the P1 and P2. Okay. Okay. So then now, let's start the problem. So first, I would like to find f prime of x. So then if I have f of x equal to 1 plus x to the power 3, then f prime of x is equal to 0 plus 3x squared, or just 3x squared then, okay? Then now, we would like to set f prime of x equal to 12. Then I have 3x squared is equal to 12. Then x squared is 12 divided by 3, which is 4. Then we take the square root of 4. But remember, we have to have a plus or minus, right? So then in this case, I have plus or minus 2. Okay. Ooh. That means when x equal to -2, then I will be able to find P1. When x equal to 2, then I will be able to find P2 then. Okay. Okay. So I would like to find P sub 1 is when x equal to 2. Then now I will have f of -2 is 1 plus -2 to the power 3. So it is -7. Okay. So then in this case, my P1 is -2, -7 then. And I would like to find P sub 2 when x equal to 2. Then I have f of 2 is 1 plus 2 to the power 3, which is 9. Okay. So then now my P sub 2 is 2, 9 then. Okay. Okay, so now we have enough information now. So if I want to find the tangent line, okay, first, maybe let us find L sub 1. Okay. The information about S of 1 is the slope of the tangent is equal to 12. And the point is -2, -7. Okay. So we found out that L sub 1 is y equal to 12x plus 17. Okay. Use the same technique. I will be able to find L sub 2. The slope of the tangent is 12. And the point is 2, 9. Okay. Again, use the point slope form. Okay. Then I will be able to make the decision that the two tangent line are y equal to 12x plus 17 and y equal to 12x minus 15. Okay. Wow. Then now let us get to our last example. Okay. Now to this example, is actually is I would like to find the derivative of the functions. Then I would like to find where the point where the original function has horizontal tangent lines. Okay. Now remember, horizontal tangent line is actually mean that the slope of the tangent is equal to 0. Right? This is what it means. Okay. Then in this case, it means that I would like to have or the set f prime of x is equal to 0. Okay. And then remember from the last package, if I set f prime of x equal to 0, meaning I'm looking for critical numbers. Okay. If I want to find the critical numbers, meaning what is related to the local maximum and minimum. So that's why you will see that C here. I would like to find the x value where f of x has a maximum or the minimum point, and where the graph of f is increasing or where the graph of f is falling, is decreasing. Okay, so that means in this case, this C right here, I would like to work with the side charge then. Of f prime now, right? Okay. Okay, so let's see how we actually work it out this problem. Okay. Then of course, first I would like to find the derivative. So I'm going to rewrite f of x equal to 7 minus 3x squared minus 1 over 3 times x to the power 3. Okay. Then f prime of x equal to, okay, so again, the derivative of 7 is 0 minus 3 times 2x minus 1/3 times 3x squared. Okay. So I have f prime of x equal to negative 6x minus x squared. Okay. Then now I'm done with A. And now we are going to work with B. So then in this case right here, I will set f prime of x equal to 0. Okay. Then I will have negative 6x minus x squared equal to 0. Then of course, in this case, what we could do here is we have common factor x. So I could take out the negative x. Then I have negative x times 6 plus x equal to 0. So then in this case, of course, x equal to 0, or 6 plus x equal to 0, where x equal to -6 then. Okay. And now we find out what x is, but we are looking for points. Okay. So now we would like to find points. When x equal to 0, then f of 0 is equal to 7. Then my first point is 0, 7. Okay. When x is equal to -6, then f of -6 is equal to 7 minus 3 times -6 to the power of 2 minus -6 to the power of 3 over 3. Okay. Okay, so then now I have 7 minus 108 plus 72. So I have like negative 108 plus 79. It is negative 29 then. Okay. Okay, so then now we have a point. In this case right here, then I have -6 and negative 29. Okay. And then now let's see how we work with C now. Okay. So again, to this C right here, we would like to create a side charge, or we need to find, in order to work with the side charge, we need to find critical numbers. So then let's see. I would like to find the critical numbers. Okay. So I would like to set f prime of x equal to 0. So, and in this case, I will have -6x minus x squared equal to 0. And of course, to this one, we know that x is equal to 0 or x is equal to -6. Okay. Then now we would like to create the side charge. Okay. For f prime. Then remember, side charge is just a number line that contain only the critical numbers. So I only write down -6 and 0. Okay. And then we need to choose a test point. Then maybe I choose a -10 with this interval from -infinity to -6. And maybe -1. Okay. It's between -6 and 0. And then maybe we could choose 1. Okay. From 0 to infinity. Okay. Then okay. Then now let's test this then. Okay. What we need to work with is, again, we need to work with f prime of x is, maybe let me write down negative x times 6 minus x, or 6 plus x then, okay? Then, again, what we need to do is, we would like to work with f prime of negative 10, okay? Then, in this case, I replace x with negative 10. Okay. Then now, you will see that the result, this one give me positive, this one give me negative. So therefore, in this case, it will be the negative then. Okay. Then how about f prime of negative 1? Okay. So I have negative, negative 1, and then 6 minus 1. Okay. So in this case, this is negative, this is negative, this is positive. So then I will have positive. Okay. And the last one, I would like to evaluate f prime of 1. So I have negative 1, 6 plus 1. Okay. Then again, remember, we don't care about the values. We only care about if it is positive or negative. So this is negative, this is positive, this is positive. So the result that I have, of course, I have negative. So then let us put this between negative infinity to negative 6, the output, okay, the side charge, maybe I could say that is negative. And then between negative 6 and 0 is positive. From 0 to infinity is negative, okay? And how do we translate this side charge, okay, relate to the function then? Okay. So now, if we look it back to the functions, then again, I label the negative 6 and 0, the critical numbers, okay? And remember, the negative, okay, if f prime is negative, meaning to the f functions is decreasing. If f prime is positive, then to the function f is increasing, okay? Between 0 and infinity, the f prime is negative, meaning to f prime, 0 to infinity is decreasing, okay? Then, of course, from decreasing to increasing, I will have a local minimum as x equal to negative 6. And from increasing to decreasing, right? So now I have the local maximum as x equal to 0. Okay. So then now we could make the conclusion now. Okay. So the conclusion is I will have the local maximum point at 0, 7. The local minimum point is at negative 6, negative 29. Okay. And now for rising, or meaning where the function increasing, okay, it will be from negative infinity to negative 6. Oh, my bad, increasing. Ooh. Then it will be from negative 6 to 0 and decreasing, or falling, right? It is between negative infinity to negative 6, union with 0 to infinity then. Okay. 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 So now, what I will do, okay, essentially is that because right now we have information about where the function increasing, decreasing, and also I have the local maximum and minimum. Then let's see if we could gathering all the information and then to see if we could sketch the function then, okay? So then let's see to this one again. I have my local maximum is as 0, 7. So here I have my local maximum. And then I have the local minimum is -6, -29. Okay. And then now, between -infinity to -6, the function is decreasing. Okay. And then between -6 and 0, the function is increasing. Okay. And now from 0 to infinity, the function is decreasing again. Okay. Then probably this will be my f function then. Okay. Okay, so thank you. That's it for this lecture now.